Recording, sir.
Who is recording?
Me, sir. Nandini.
Okay, right. It's recording now. Okay, right, good. Okay, are you recording in the cloud or?
Yeah, sir. Recording in cloud.
Huh?
Recording in cloud itself, sir.
Cloud. Okay, right, good. So this is what, and the if the it happens to be the priority, topmost priority, that is on to the left, then only it has to be inserted before that particular this one. So now very important here is when you are inserting at the left, okay. So this is what actually not insert normal this one. You see, if priority what you have given is less than priority of I, okay. So from where you start the value of I is equal to, which started from where. So I minus minus you keep doing it, and till when you are going to complete that I minus minus you are going to do it. That is your priority of priority is less than priority of I. Okay, then this is what you have to do it. Okay, so this we have to keep doing it. A priority of I plus 1 is equal to priority of I. This will continue. So once you find that the condition is not met, right? The priority is less than priority of I, then we have to stop. So no movement would be there. And then we have to assign PR of I plus 1 is equal to PRI, and PR of whatever is that Q of I plus 1 is equal to L. So when we wanted to insert it as for that is when you want to insert it as the leftmost element, it's very simple. When front, okay, that is not a problem. But when front is equal to 0, then front should be set as equal to max minus 1, and then assign PR of front is equal to PRI and Q of front is equal to. When PRI is less than PR front, right? That is two cases arise when front is equal to 0 or front minus minus. When PRI is greater than PR or rear, then again two cases arise. Rear is equal to max minus 1, then rear has to move to the 0 location. So rear is equal to 0, and then assign. Otherwise, you are going to do rear plus plus, right? So taking this into this one, now let us write a program for this. So let us write. Today's date is 19th May 1. Okay. So hash include stdio.h. Okay. Right. So what are the things which you require here? Now tell me, what are the things which you require? You are using an array, right? Array representation, right? So what are the things which you are going to take globally here? Now, first of all, as define max, let us take 10, and then int we'll have q. So that is what q we are saying. For example, this is parity q. So pq, right? Let us take pq of max is one array. The other one is priority. So PR of max. Okay. And what else you are going to you are require? What else you require front equal to -1, and where is equal to -1? Where is equal to -1? Is this clear? Okay, right? So these are declarations, and what are the functions you have? Void p priority q insert, priority q insert. Let us call is one function. Void priority q delete is another function, So PQ delete is not a problem. Don't use delete, right? And normal in the queue, what are the function names you are going to use? NQ you are going to use for insertion. DQ you are going to use for deletions, right? Okay. That is only for the normal queues. The other queues you can give the names like PQ insert, void PQ delete, and then void display as usual. Okay, right? And since it is an array, we want to check whether it is empty or not. So int is empty and int is full. And then void main. Okay, so void main. What is that we are going to write in the menu here? Menu number one is insert. Number two is delete. Number three is display. Number four, exit. So, okay. So these are the things which we are going to have. Now let us use the what is that called? Let us now first do the what is this one? What is that called? Insert. Okay. So let us write void to insert. I require an priority that which will take it as P. Priority is P. Element is required EL. Let us take EL. Okay. And I you require an I. Okay. Like you have seen I. So this is required. And these are the things which are required. Now, first of all, what is when the insertion is possible only when the queue is not full, right? So, what I am going to do if is full is returned, then printf queue is full. Queue is full, right? So you know when the queue is full, queue when is that when front is equal to where plus one. That we already done, right? That condition that you are going to write. Okay, that you are going to write for is full and is empty also. You know, when front is equal to -1, then it is empty. Okay, so the else part for this is what? What is the else part? When the element can be inserted. The element can be inserted. Okay, so let us take printf enter the element. So where are we going to store this? Scanf percentage d ampersand el. And here one more thing is required to be taken. What is the priority also? Enter the priority of the element. The priority is 1, 2, 3, 10, whatever. So let us store that priority in percentage d ampersand p. We are storing it in p. Is this clear till now? If this is clear, then we'll go for the next service. Okay. So priority is required, the element is required. Now the first and foremost is it is the already the queue is empty, for example. Already the queue is empty. When queue is empty means what? It is only the first priority. It is itself is the first. Yes or no? So we require why this is required to be checked is because the rear value and the front value both have to be set to 0. Both have to be set to 0, right? And then assign the value. That is what is very, very important. Okay. So I'm checking whether it is empty or not. When it is empty or not, when the front is equal to -1, then the nothing but when front is equal to -1, the queue does not have any elements, right? So I'm going to the next page, please, right? And I'll tell you that. You have made a note of it. I'll go to the next page. Okay. So what is to be checked here? And check if friend is equal to -1, then it is a first element. So I'm going to set friend as equal to rare is equal to 0. Set it as equal to 0. Friend is equal to rare is equal to 0. Now assign what is q of pq, right? Pq of friend or rare, whatever, right? Rare is equal to element. And what is PR of rare is equal to priority. Priority value is P. We have taken only P, right? Only P. Okay, right? So is this clear? So we are assigning the P, that is in the first location itself. We are taking the value of element. We are putting it in the array of PQ, and priority we are putting it in the okay. So this is what is a simple for when friend is equal to -1. When friend is not equal to -1, then what does that mean? It is nothing but
Not
what?
first.
Huh? Yeah,
It's
what does
not
that
the
mean?
first node.
Yes. So I have to go for the else part now. Okay, right? I have to go for the else part. So else, yeah. In the else part, we may require that if the priority of the incoming one is less than the priority of the first element which is available in the queue, what does that mean? It has to come to the left. It has to come to the left.
Yes.
Okay, so I'll check for if P is less than, P is less than, okay, if P is less than
PR of
P
rare.
of friend, P of friend, okay. If that is the case, then it has to be come to the first position. Now in this you don't know whether the friend is at 0 or otherwise. So if it is 0, what are we supposed to do? We have to
Friend
move the
equals
friend
to max minus
max
1.
-1, we have to do it. So again I am going to check if friend is equal to 0, then we are going to set it as friend is equal to max -1. Right? Anyhow, we have to do it in both the case. If friend is equal to 0, this one we have to do it, or otherwise also. So the else part for this would be, right? Else part would be simply if friend is not equal to minus this one, where we have to do friend minus minus. So we are going to do friend minus minus. That's all. There are only if friend is equal to 0, friend is equal to max -1, else friend minus minus. Now, if this, I'll take bracket for this out. Now, if this is done, after this, the statement is you have to assign the element to Q of friend. So PQ of friend is equal to element. And also priority you have to assign. PR of a friend is equal to P. And then close this if statement, that is which was P is less than PR of friend. After this, the else statement for this, let us take now the else statement for this. What is the else statement for this now? Tell me. I am going to check whether it is onto the right hand side. So how to check whether it is to the right hand side? If P is greater than PR of rare, PR of rare, then what does that mean? Okay, greater than or equal to also you can take it. Greater than or equal to also you can take it, because but for first one you should not be less than equal to. Why? Because if already the front element priority is 5, the new element priority is also 5, then it should not be put in front of that for front element. You should put after 5 element. there we have to follow the first come first serve. Okay, so it's very, very important that if there are two elements which have got the same president, already existing element has got presidents and the incoming element has got a president, both are same, then the incoming element will be always behind the element which is already existing. That you should remember. So that is the reason P is less than PR front only we are going to do it. But in the rear, it has to come behind only, right? So we are going to take P is greater than or equal to PR for this. In this particular case, again, there are two cases. What is that particular case? If rear is equal to rear plus you are going to do it. But when rear is already equal to max minus 1, what will happen? It will overflow, right? So we have to set it to 0. So I'm going to set it as if rear is equal to max minus 1, then you simply set it as rear is equal to 0. Else, what I'm going to do? Rear plus we do it. Right? I have not used this one, only one single statements are there. If now under this particular, what is going to come next? You please make a note of it. Now we are going to do PQ of rear is equal to element and PR of rear is equal to P. Right? So that are the two steps which are going to follow this particular if. Okay, so please make a note. Next, this page will go. Okay. You made a note? You have lab today, right?
Sir.
So what are you doing in the lab as of now? What is that? What happened in the last lab?
Ma'am said single link list, sir.
Linked list now also. You have already completed stack queues. When are you going to do?
Today we will start stacks.
Huh?
Today
W
we will
linked
start
list is
stacks.
over. W linked list.
For batch 1 only single link list not completed, sir.
Sir, batch 2 ma'am said to do as well.
Okay, we'll go to the next page. So what is this? We are going to write now the statements. So PQ of where is equal to element and PR of where is equal to P. Now close the if. Close the if. Now another else statement will come for this. What is the other else statement for this? Now tell me. What is the else statement for this?
In between front and rear.
Yes, it is in between. It is in between. So in between means what are we going to do? I is equal to, let us set it as equal to rear. I is equal to rear. Take a for loop or while. What is the condition we have taken? You remember what is the condition we have written? I have given you an example. What is the condition? PR of if PR if P is less than, when P is less than PR of
I.
PR of I. Okay, what are we going to do here? Come on, tell me. What are we going to do here?
PR
of PR of
I plus 1 equal
I plus 1 is equal to PR of I, and then PQ of I plus 1 is equal to PQ of I. Okay, and then we have to do I minus minus. Okay, that's it. This is what after this what are we supposed to do? We have moved, and now finally we are supposed to do PR of I plus 1 is equal to priority has to be inserted, right? So how to do that? This one now tell me after what the condition. Yes, PR of I is I or I plus 1.
I only know.
Yeah.
I only.
No. Where does it move? PR of because I minus minus when it has come, so it has I plus 1 is the position where you are going to insert I plus 1. So it is PR of I, PR of I plus 1 is equal to, we are going to write it as P, and PQ of I plus 1 is equal to element. That's all. Is this else is closed. Now please start closing all the else and everything now. So whichever you have started, one else has started for enter the element, that is not closed. If there is one more else which has opened, there's one more else which has been opened, there's one more else. So else, I will, how many else? First one else is opened, thereafter one more else is open, thereafter one more else is open. So these else, 2, 3, one more else, and then void. Total, everything is closed. Okay, so this is what is your insertion in the priority queue. Okay, now let us do the deletion. Okay, so please make a note of it. Deletion is very simple. What is deletion now? Tell me. Is it required to be written? You have already done. What is the deletion?
And
Frontmost element has to be deleted.
yes,
Yes or
sir.
no?
Yes, sir.
Okay. That's all. So if front is equal to, right?
Minus.
Front and rear both are same. What does that mean? It is only one element. Okay. Then what will happen? Front and rear both are to be set as equal to -1. Okay. This is your Q. Okay, for example, front is here and rear is also here only. For example, this is 55. Now, what will happen actually? The problem here is this element gets deleted. Then front and rear both actually when we do the deletion, what is being done? Front plus plus. But there is no other element here. That means when only single most element is there, then front is equal to rear. When front is equal to rear, then what are we supposed to do? Nothing but front should be equal to 0 and -1, and rear should be equal to -1. That is how we have to do it. Okay, one single element is there. When single element is there. So this is one case. The other case I will tell you, when the front is here, when your element
Last.
front is here, and the elements are the other elements are, for example, it is like this. The 35 is here, 40 is here, 45 is here, rear is here. Now what will happen when front is being deleted? This particular 55 is deleted, then front is moving from here to here. So
Zero.
if front is equal to max -1, then what are we supposed to do? Front
Front equals
should be
to
equal
zero.
to, yes,
Zero.
it should be equal to 0. Okay, right? And otherwise, what will happen? Front is going to be plus. So this is what is the deletion concept. Okay, so let us do this deletion. This one, write the deletion function. Okay, so void priority queue delete. Okay, you require an int element. So priority actually which priority element is being deleted, you want to print, you can take PR, otherwise not required only. Okay. So first of all, what is required to check? If it is empty, you cannot delete, right? So I have to check for what now? If is empty. If is empty, then printf Q is empty. Q is empty. So no deletion takes place. Else we are going to delete. Now when we are deleting, what is to be first checked is I'll check if friend is equal to where. Then there is only one element. So first of all, element is equal to, I'm going to take Q of PQ of friend. PQ of friend. Okay. And what are we going to do? Simply friend is equal to -1 and where is equal to -1. Is this clear? If front is equal to where? Are we doing anything with PR of front? Nothing. PR of that becomes automatically garbage. This one only. Front is being changed. That's all. Okay. But we want to know which element has been deleted. We want to display it. That is the reason we have taken EL is equal. Now the else part for this is what now? Tell me. Else again if front is equal to max minus
minus
1, right? Then what are we going to do? Simply set front as equal to 0. Before setting the front as equal to 0, what are we going to do? Element is equal to PQ of front. And then front is equal to 0. Front is equal to 0. Right? That's all. This is what. And the else part for this is what now? Tell me. Else part for this is simply
Front plus
element is equal
element.
to PQ of front and do front plus plus. Front plus plus. Right. Now after this complete before closing the else part, what are we going to do? Printf element deleted is percentile D measure and EL. Then close the else. Then close your. So all the else are being closed or not? There is one else if only statement is there, that's not a problem. So that this else does not require closing because we have not opened it. Okay. But under only one statement is there, if so, not a problem. So this else has been closed, right? And now close up void. Is this one clear? I will not how you know how to display. I will not touch. You know how to display, right? So how to display, you know. I will not once again tell you the same thing. Display is same. Okay, right? So that's not a problem. If you want to display the element and is what is that called priority, then that also you can do it. That's not a problem. Okay. Right. So now let us go for this. You have made a note. Then we go for the linked list. Priority queue using linked list. Priority queue using linked list is very easy. Okay. Implementation of priority queue using linked list. Okay. So how does it work? Now I require a priority. I require a data field. Okay. So till now we are only taking the data field and the what is that other field you are taking? Simply you are taking the address field, right? So now I have this is the address field I'll take, and this is the value field I'll take, and this is the priority field I'll take. Priority field. So how to declare the pointer now? Tell me, right? how to declare this node, right? We can how to declare this node. Tell me, what are the fields you are going to have? If only the value was there, you have taken int data and address field you have taken. Now you have two, this one. One is int priority, the other is int data. Okay, that is what is going to be taken. So we can take it node as what now, right? Struct, for example, PQ, if I give it, okay, then int data, you take int priority and struct, right? What is that? PQ, right? Star
Not PT.
PTR. Is this clear? Then how to declare this one, right? Now, what you do is you have the header. Okay. Now you have the node, first node, the second node, the third node, like this. Now what will happen here is, if you, this is front, this is rear. Okay, so this is at 3562, this is at 2892, this is at 6166. So this is going to be what? 6166 rear, and this is going to be 3562. And what is this 2892? And this is going to be 6166, and this is going to be null pointer. Okay, so for example, values the values are 55, 82, 96, and priorities. This is fifth priority. For example, this is eighth priority, and this is 10th priority. Okay. Now let us take one value is going to come. Okay, I will say insert, right, with the data as a 75 with priority 3. Priority 3. So what if this is priority and this is what the value. Now where does this come? This new node. Now tell me, where does it come? It comes in front
First
of
node.
first node. Why? Because it is 3 is less than 5. 3 is less than 5. Are you getting the point or not? Okay. For example, I want to insert 95 with the 9. Where does it come? Now tell me. In front, in front of 10. Got it or not? As third node. Right. Similarly, I'll say insert 125 with 15 as a priority. Where does it come? It comes after. So there are 3 cases, right? Case 1 is what? Lowest priority. Lowest priority. Then it is inserted as first node logic. First node logic. Right? Case 2 is highest priority. That is, okay, that is last node logic. And case 3 is in between priority. In between priority, then it is in between node. In between node logic. Okay, one more would be there, case 4, right? When Q is empty, then the node inserted is first and as well as last node. Yes or no? First thing what we are supposed to do, actually this is case 1 and this is case 2, this is case 3 and this is case 4. Got it or not? This is case 1. What is the case 1? First we have to check whether the queue is empty. If the queue is empty, then it is the first node as well as the last node. The priority checking not required. Otherwise, the priority checking starts now. Now, how do you check the priority? How do you compare? How do you compare? Right? We are going to how to access the priority field of the first node? How to access the
Front
priority
arrow,
field?
PR.
Front arrow PR. Right? If the given priority is less than, that is the new node arrow priority is less than front arrow priority, then it has to be inserted as a first node logic. First node. Okay, right? Else, if the new node arrow priority is greater than or equal to the rear arrow priority, it has to be inserted as the last node logic. Else, it has to be inserted as in between node logic. So in between means, what are we going to do? We are going to set temp. We are going to take it. Okay. So we are going to see that whatever is the temp arrow, that means we are going to till when we are going to continue this movement. Tell me now, until you come to that particular this one. So till the new node arrow PRI is greater, is less than or greater than, is greater, right? Is greater than the temp arrow PRI. It will continue. It will continue. So once it is right, or actually the less, that means PRI of the temp is less than new node of this one, less than or equal to, it will continue. Once it becomes greater, it will stop. That's all. That's what we are going to do it now. Okay. So let us take this particular this one and write down the program for this, right? So you know the lower highest, that basically in the linked list, what we are doing here is we are having the three fields: address field, value field, and the priority field. That's what is the difference here. So we are checking the priority, right, of the new node what is coming in. That's all. Okay. So let us write the program for this now. Insertion. Deletion is very simple. What is the deletion? Tell me. What is deletion? The first node has to be deleted. That's all. It's very, very simple. Deletion is very, very simple. Okay, that's not a problem. Okay, right. So let us write. I'm directly writing the function only. Okay, right. Okay, let us write as include stdio.h and what is that? Type def struct pq int data int pri, okay, priority, and then struct pq star ptr, the pointer node. So node is a this one which I am going to use. So node star friend is equal to null, comma where also equal to null. Star where is equal to null. Okay, right. To this one you have taken, and then anything else? Void functions are there. Void pq insert, void pq delete, and void display. You already know this. Okay, right. Then what else? Right, void. And we have to check for empty. Is full is going to be when the memory is not allocated. So check for empty. You int is empty. Is empty. When it is empty, tell me. When it is empty, when front is equal to null. Front is equal to null. Okay, right. So void main. So the everything is same, the same one. Now let us take void. First is what? PQ insert. So when that is, let us take node star new node. Let us take int P is the priority, EL is the element. Okay, right? So first what we have to do, new node is equal to node star malloc function, so that your memory is allocated size of node. Why we have done this first is, if new node is equal to null, then I'm going to printf memory not allocated. Is this clear? When the memory is not allocated, when new node is equal to null, that means when the function malloc function returns null pointer, then new node will be equal to null. Then that means that the particular this one has not been so memory not allocated. Okay. Now the else part for this, I'm going to the next page. Else part. Okay, there we are going to write the function actually. So else.
1 minute.
I've already gone, that is already known. The else part. The else part. What is the else part? Is already the memory has been allocated. So first you do is printf enter value. Store it in element. Then enter priority. Store it in P ampersand. Sorry, ampersand. Okay. Store it in P. And now assign the values to new node. New node arrow data is equal to L. New node arrow PRI is equal to P. And new node arrow PTR is equal to null. So once this is being done, now we have to start inserting it. So first and foremost, there are chances that case one which I have told. What is that? If front is equal to null, it is what? Nothing but the only node logic. So what is going to happen now? Tell me. If front is equal to null, then
Front
our
equals to new node.
yes, front is equal to new node and rear is equal to new node. Okay, right. Else part for this, tell me, else part. Else part I am checking for now. I'm checking for the priority is less than. So
Yes, sir.
I'll check
If
what. Yes, what is that we are going to check? Right, the first node priority, new node, that is if new node arrow PRI is less than the front arrow PRI, then it is the first node logic. Now, first node logic, should I write it here or you know? You know, from there you carry forward this first node logic. I'm not writing the this one here. You know what is the first node logic, how to do it. Okay, right? So that is first node logic. Now else I'll check for if new node arrow PRI is greater than or equal to front, rear arrow PRI. If that is the case, it is this is first node logic. And this is a last node logic. Okay. So is this clear till now? Okay. Now the else part for this is what? Now let us go for the else part. Else part is what now? You have to take a temp. Did we take a temp actually here? We have not taken a temp. Take a temp also. New star new node and
I
also.
also we have.
Why IU required? Tell me. Why IU required?
Sir,
I
to
is
move
not.
the temp now, sir.
No, move the temp. You move the temp. When I'm going to move, I'm comparing temp arrow PRI. Is it less than? If it is less than new node arrow PRI less than or equal to, we are going to move, right? So I don't require. Right? So we are going to the next page. Please make a note of it. Next page I'll go. Next page. So we don't require I because number of nodes are not known. You don't require I is equal to that, not required. Okay. Else temp is equal to what is temp is equal to? Tell me. Temp is equal to what is the initialization value of temp?
Front arrow PRI.
Front arrow. Temp.
Sir, front arrow PRI.
Front. What is temp? Temp is the address. It is a node. It is front. It is front. Okay. Now we are going to check while temp arrow PRI is less than or equal to new node arrow PRI. We have to keep moving this. How to move? Temp is equal to temp arrow PTR. You are moving. So you have moved. And it has come to the right place, right? Now you know how to handle it, right? How to insert it. So how to insert it, you know, right? So that you can do it. So now you write down in between node insert logic. That's all. Okay. So this is what is this one. So how are we moving is simply temp is equal to temp arrow PTR, we are moving, but how temp arrow PRI is less than or equal to new node arrow PRI. So then you are moving, right? So what is the in-between node logic? When you reach to the in-between node, we have written a single linked list. Go back to your single linked list, everyone.
Yes, sir.
Go back to your single linked list. And how are we inserting that? Temp has come to the position now. What are we going to do now? So temp, right? So temp arrow PTR should be equal to what? New node, right? But before that, you have to do new node arrow PTR should be equal to temp arrow PTR, and thereafter temp arrow PTR is equal to new node, right? So that is what is required. So what is that? Simply, should I write it here? So new node arrow PTR is equal to temp arrow PTR. The next node address is being stored in new node arrow PTR. And now you are going to say temp arrow PTR is equal to new node. So that this is what is the, so that we have inserted, that's all. Okay. So this is what. Okay. Right. Now come to the deletion. So all these are going to be closed. So void PQ delete. So take node star temp. Okay. Node star temp. So first node has to be only deleted. So I will take int n. Okay. First I am going to check if is empty. When it is empty, when front is equal to yes, right? So printf q is empty. Okay. and else now write down if friend is equal to rare, then what does that mean? It is only the single node. It is the only single node, right? So what have to be done now? We have to first set temp is equal to friend, okay? Then friend is equal to null, rare is equal to null. Both have to be set to null, and then very important, element is equal to
temp arrow data.
temp arrow data, temp arrow data. Okay. Now we are going to say what is free temp, free temp. So this is what is the when friend is equal to rare, that is only one node is there. Only one node is there. Now assume one node is not there. One node is not there. Then what will happen? Then what will happen? Now tell me. If only one node is there, that is the case. If one node is not there, then what will happen? You have to delete the first node. Okay, you have to delete the first node. So how to delete the first node now? Okay, the else part for this. Else part. Okay, so temp is equal to friend. Temp is equal to friend. Now how to delete the first one? This one. Tell me now. Friend is equal.
Temp arrow PTR.
Friend is equal to front arrow PTR or temp arrow PTR. Then element is equal to temp arrow data. Okay, and then free
temp.
So this is how you are deleting the first this one. So completely close. Element deleted, you can write what printf. Element deleted is %d/t el. Close up. Now this is what is a deletion. Display, I don't want to say same display, same thing. Once again, no repetitions, please. Okay. And now very important is complexity of this priority queue. What is the complexity of a priority queue? Let us take using arrays first. Using arrays. Using arrays, when you are inserting it as the first element, right? When the priority is less, then it is big O of inserting as first element, then big O of 1. Inserting as last element is also big O of 1. Insertion in between what? Tell me. In between big O of big O of n. This is what is the. Now let us take deletion. Deletion is always first element only. Always first element. So big O of 1. Big O. Is this clear? Why the complexity of insertion in between is big O of n? Because the elements n comparisons has taken place, so it will move, right? Now let us take using linked list. Doing linked list. Inserting as a first node, it is big O of 1. Inserting as last node in the priorities, that is also big O of 1. Inserting as in between node. In between node, big O of n. Big O of n. Now tell me deletion. 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 Tell me. Deletion is always
Big O of 1.
is big O of 1 only. Big O of 1. Is this clear complexity? Right? Is the complexity clear? Okay. So tomorrow we are going to start with a new topic, new unit. Okay. Tell me what is the attendance for today? Today's date is 9th May 2021. One period of 17.